I'm asking you to identify the correct statements about the properties of the matrices W and H that result from applying non-negative matrix factorization, NMF. We'll explore the characteristics of these matrices, their elements, dimensions, and the relationship between their product and the original matrix. This statement checks if all the numbers in both matrices W and H are 0 or positive. This is a core property of NMF. This statement verifies that the matrix W has a number of rows equal to the number of documents and a number of columns equal to the number of topics that I chose during the NMF process. This statement checks that matrix H has a number of rows equal to the number of topics and a number of columns equal to the number of unique words in all the documents. This statement asks whether multiplying matrix W by matrix H gives you the original document term matrix exactly. In NMF, this isn't usually the case. It's an approximation, not a perfect reconstruction. This statement gives context. I use a specific technique called non-negative matrix factorization, NMF, in the Sklearn library. NMF is a method to decompose matrices, focusing on keeping values positive or 0. This is my input data. I'm starting with a table where rows represent documents and columns represent words. Each cell shows how often a specific word appears in a document. This is one of the output matrices. The rows represent documents, and columns represent topics. Each value shows how much a topic is present in a particular document. This is the other output matrix. Rows represent topics, and columns represent words. Each cell indicates how important a word is to a particular topic. This question asks you to identify the true statements about the properties of the matrices W and H that result from applying non-negative matrix factorization. We'll examine each statement to determine its accuracy based on how NMF works. This is correct. W is the document topic matrix. It shows how much each document relates to each topic. So, the rows represent documents, and the columns represent topics. Absolutely correct. The matrix H is the topic word matrix. This matrix illustrates the importance of each word in defining each topic. The rows show the topics, and the columns show the words. That's right. A core feature of NMF is that all values in the resulting matrices, W and H, must be non-negative. This is what the non-negative in non-negative matrix factorization refers to. This statement is false. The operation W at H, matrix multiplication of W and H, produces an approximation of the original matrix, not a perfect reconstruction. NMF is inherently an approximate factorization technique. Some information is lost in the decomposition process. This question asks about the characteristics of the matrices W and H that result from applying non-negative matrix factorization, NMF, to a document term matrix. Specifically, it wants to know about the signs of the numbers in the matrices, their dimensions, and whether they perfectly reconstruct the original document term matrix. I'll explain what each characteristic means. This statement says that every number in both matrices W and H is 0 or positive. This is a key feature of NMF. NMF only uses non-negative numbers. Think of it like this. You're breaking down a recipe, the document term matrix, into ingredients, topics, and their amounts. W and H. You can't have negative amounts of ingredients. Matrix W shows how much each document relates to each topic. The number of rows is the number of documents, and the number of columns is the number of topics I specified in my NMF model. So, if I have 10 documents and identified 3 topics, W will have 10 rows and 3 columns. Matrix H shows how important each word is to each topic. The number of rows is the number of topics, and the number of columns is the number of words in my vocabulary. For example, if I found 3 topics and have a 1,000-word vocabulary, H will be 3 rows by 1,000 columns. This statement is false. The matrix multiplication of W and H, W at H, which means multiplying the matrices and adding the results, is intended to approximate the original document term matrix, not perfectly reconstruct it. Think of it like a photo. NMF takes a high-resolution photo and simplifies it into 3 sketches. Each sketch, topics, is like a summary, and when they're combined they should resemble the original but will not be exactly the same. I use non-negative matrix factorization, or NMF for short, a technique from the Sklearn library. It's a way to break down a big matrix into smaller, easier to understand parts. Think of it like separating a complex recipe into its individual ingredients. This is the starting point, a table showing how often each word appears in each document. It's the recipe we want to simplify. I use NMF to break down this document term matrix. I've set n_components equals 3 meaning I'm looking for 3 underlying topics within the documents. This is like identifying 3 main ingredient categories in a recipe. This resulting matrix shows how much each document relates to each of those 3 topics I've identified. It's a measure of the ingredient category distribution in each recipe. This matrix shows how strongly each word is associated with each of the 3 topics. It gives me the ingredient profile for each ingredient category. Matrix W's shape is determined by the number of documents and the number of topics. It's like saying the recipe matrix has a row for every recipe and a column for every ingredient category. Matrix H's shape is dictated by the number of topics and the number of unique words in the entire collection of documents. This means H has a row for each ingredient category and a column for every ingredient. Because of the nature of NMF, all the numbers in both matrices will be 0 or positive, no negative values. It is like saying you can't have a negative amount of an ingredient. This statement correctly describes the shape of matrix W as the number of documents by the number of topics. This accurately reflects the structure of matrix H, the number of topics by the number of unique words. This is wrong. NMF only gives an approximation. Multiplying W and H won't precisely recreate the original document term matrix. It's like saying that combining the ingredient categories and their ingredients won't perfectly recreate the original recipe. There's bound to be some small differences. I'm using NMF, a technique from the Sklearn library, to break down a document term matrix. This matrix shows how often each word appears in a set of documents. Think of it like a spreadsheet where rows are documents and columns are words. The numbers inside represent word counts. The goal is to decompose this document term matrix. We're using NMF to do that. I start with a document term matrix. That's my input for the NMF algorithm. I set up my NMF model and tell it to find 3 topics. This means I'm looking for underlying themes that group similar words together across the documents. The output of NMF consists of 2 matrices, W and H. W shows how strongly each document relates to each of the 3 topics. H shows how strongly each word relates to each of the 3 topics. This is the quiz question. I need to determine which statements correctly describe the properties of the W and H matrices after I've run the NMF algorithm. This statement highlights a key feature of NMF. All the values in both W and H will be 0 or positive. They will never be negative. That's because NMF is specifically designed to work with non-negative data. This statement correctly explains that W will have a number of rows equal to the number of documents and a number of columns equal to the number of topics I specified. 3 in this case. The dimensions of H are a number of rows equal to the number of topics, 3, and a number of columns equal to the number of words in my original document term matrix. This statement is incorrect. NMF doesn't reconstruct the original matrix perfectly, it creates an approximation. The matrix multiplication of W and H will be close to the original, but not identical. This refers to the document topic matrix, the result of applying NMF. This refers to the topic word matrix, the other result of the NMF process. I see you're working with non-negative matrix factorization, or NMF for short. It's a cool technique used to break down a large matrix into 2 smaller, easier to manage matrices. Think of it like simplifying a complex recipe into 2 simpler lists of ingredients. This question tests your understanding of NMF's properties, specifically when you use it to analyze word frequencies in documents. We'll examine the properties of the resulting matrices to see which statements are accurate. I'm referring to the original data matrix here. It shows how often each word appears in each document. Each row represents a document, and each column a word. The values inside the matrix represent how many times each word occurs in the document. This matrix, W, is one of the outputs of the NMF process. Each row represents a document, and each column represents a topic we've identified using NMF. The values in this matrix show how strongly each document relates to each topic. For example, a high value indicates a strong relationship. H, the second output matrix from NMF, shows the relationship between topics and words. Each row represents a topic, and each column represents a word. The values indicate how strongly each word is associated with each topic. Imagine it as a word cloud for each topic. A high value means the word is very important for that particular topic. I'm using NMF, a technique from the Sklearn library, to break down a document term matrix. This matrix shows how often words appear in a bunch of documents. Think of it as a spreadsheet where each row is a document and each column is a word. The numbers in the spreadsheet tell you how many times each word shows up in each document. This question tests your understanding of how NMF works. After you run NMF, you get two matrices, W and H. I want you to choose the statements that are correct based on the nature of these matrices. This statement says all the numbers in both W and H are 0 or positive. This is a core feature of NMF. Matrix W shows how much each document relates to each topic. The number of rows represents the documents, and the number of columns represents the topics. Matrix H displays how important each word is to each topic. The number of rows represents the topics, and the number of columns represents the words. This statement claims multiplying W and H together gives me back the original document term matrix perfectly. This is incorrect. NMF only gives an approximation, it's not a perfect reconstruction. There is some loss of information. This is your starting point. It's a matrix showing the frequency of words in each document. I'm applying NMF with 3 topics. This means I'll get 3 sets of topic word and document topic distributions. W is the result of NMF. It shows the relationship between documents and the topics I've extracted. H is another result of NMF. It shows the relationship between the topics and the words in the documents.